Hey guys, we are on lesson 5 of unit 6. We're working with data in line plots. You'll see today that we're going to be able to use information presented in line plots to solve problems, including problems about redistributing measurement data. We're going to be able to perform operations with multi-digit whole numbers and with decimals to the hundredths. We're also going to be able to use equivalent fractions as a strategy to add and subtract fractions, along with representing and interpreting data. Let's go ahead and look at our warm-up here. Here we want to rename each fraction as a mixed number and each mixed number as a fraction. So you'll see you have 3 different numbers here. We have 5/3, we have 1 4/5, and we have 21/5. So again, you're either renaming the improper fraction as a mixed number or you're renaming the mixed number as an improper fraction. Go ahead and pause your video, work these 3 out, and come back and let's check our answers together. All right, so 5/3, you can see here my thinking, it's a little messy, but I said that 5/3 is the same or equal to 5 divided by 3. And I know that that equals 1 with a remainder of 2/3, so 1 2/3. Remember, we can also check to make sure that thinking is correct by taking 3 times 1, which is 3, and then 3 plus 2, which is that 5/3. So 1 2/3 checks off. We're going to use that same method that we just used to check our work to create an improper fraction for 1 4/5. So remember, I'm going to take my denominator times my whole number. So 5 times 1, which would be 5. And then we're going to add that to the numerator. So 5 plus 4, which is going to give me 9/5. And we should be able to check that by doing this method, 9 divided by 5. And we know we would get 1 with a remainder of 4. And finally, our last one, 21/5. We're going to do that same thing of 21 divided by 5. So when we think about how many times can 5 go into 21 without going over, that would be 4. And we would have 1 left over, which would give us 1/5. And again, let's check that thinking by taking 4 times 5, which is 20, and 20 plus 1, which would give us that 21/5. Hopefully that was a review for you. If not, you should be able to go back and look at the past unit videos or look at IXL skills to help you with fractions to mixed numbers and mixed numbers to fractions. Let's look at our math message here. It says, a city zoo has an orangutan that is blank inches tall standing upright. Is the orangutan taller or shorter than a 5th grade student? So here we would be collecting data. So unfortunately with virtual, we can't really collect our class data in time for this lesson. So what we're going to do is just talk through it, and then we'll look at the math journal. So yesterday's lesson was, or previous lessons was all about line plots, and today we're going to continue using those, and we're going to organize measurement data. So we're going to be using what we saw here, fractions and mixed numbers, and connecting it to line plots. So the reason comparison is difficult is that a class height line plot shows so many different data points. So it is easier to answer questions if you could just come up with one height measurement that represents a typical 5th grader. When we see that word typical, we think of average or even it out. So if we take a look at this, so one way to find a typical value, like I said, is to find the average or even out the data points. So say that these two sticks of cubes represented data we collected. We see in this first one, we've got 1, 2, 3, 4, 5. And then the second we have 1, 2, 3. So if we wanted to find the typical value or the average, we could even it out. Imagine that these represent those 2 data points and of the heights of 2 towers. If we even them out, what would we do here? This one's got 5, this one's got 3. So what could we do? Hopefully, you said that we could move one of these from the 5 over to the 3. You'd move one block to even it out, and so you'd see that the typical height was 1, 2, 3, 4 cubes in the tower. So a way to look at it is also to combine the height. We could do 5 plus 3, which equals 8, and then we divide that into two groups. That is another way of evening them out, finding the typical, or like I said, finding the average. The 2 represents the number of towers or the amount of data that we've collected. So here we have 2 pieces of data, the 5 and the 3. So we add them together and we divide them or even them out, giving that 4. So there are 2 different ways of doing the exact same thing. So if we have this data, these 3 towers, we've got a 9, 8, and 4. We've got 3 pieces of data here. We want to even it out. We want to find the typical height of towers or find the average height. What do you think we would do for this? If in the last one we added the 2, would we add the 3 heights together? Maybe take 9 plus 8 plus 4, and then what would we divide it by? Hopefully you said 3 because we had 3 towers, 3 pieces of data. So we took 4 plus 8 plus 9 and then divided by 3. So if I'm doing that, I'm going to see here that 4 plus 8 is 12 plus 9. And then I'm going to take 12 plus 9, which we see that we would get 21. And then we're going to divide that by 3 because there are 3 pieces of data that we collected or 3 towers that we're looking at. So all of them together divided by 3, and that would tell us that the typical height or the average height would be 7 blocks. So moving forward to even bigger data, because like we said in that math message, they wanted people to collect data for their entire classroom. Let me go up here, their entire classroom, or maybe their entire grade. So that's a lot more than 2 or 3 pieces of data. Here, they're moving in that direction. We see that here is some data. We don't know what this data connects to, but they've given us the data here. We've got 1, 2, 5, 8, 2, 3, 7, 8, 10. What rule could we implement or put towards this data to find out the average, the typical? What do you think we could do here? Hopefully, you said add all of these numbers up. So 1 plus 2 plus 5 plus 8 plus 2 plus 3 plus 7 plus 8 plus 10. And then to even it out, you want to divide it up evenly by how many groups you have. So we can see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we would take the addition of these and divide it by 9 groups. So why don't we use that calculator again? Got some different calculators popping up there. But we can take our information that we collected, and so we have 1 plus 2 plus 5 plus 8. I'm going to start with that. 1 plus 2 plus 5 plus 8. And then we're going to add 2 plus 3 plus 7. 2 plus 3 plus 7 plus, we get our last 2, 8 plus 10. So I'm just going to do 18 because I know that. So we get 46. And we said that we had 9 pieces of data. So we're going to divide that by 9 pieces of data. We get 5.1111 repeated. So that would give us the average. What we could say here is maybe 5 and 1/10, or 5.11, 5.111, or 5 and 111 thousandths. Notice that they don't always come out perfectly, but that tells us what the average is. So answering the math message question would be difficult because there'd be so many different data points from students' heights. How do you think we could use what we just talked about, what we just learned about evening out data to answer that question? I want you to go ahead and look at page 207 in your journal to review some data. And ask yourself this: how can we use this information here to help us find the typical height of a 5th grader? What can we do there? So if we head over to page 207, again, I'll just show you a reminder of how to get to the SRB, student reference book. We look at page 207. Is that the correct? Yeah. Oh, we're using our journal. My apologies, not our SRB. But we'll look that up in our SRB in a minute. How can we use the information on 207 to review data? Well, if we're using class data as results, we would be able to find the typical height. What we could do there is, if our class data results in a fractional dividend, we could consider the following. We could either ignore the fraction, or we could use that fraction to round up. So just like this one here, where we came to the answer of 5.1, we could report it as a fraction, or we could use it to decide, okay, what could we round to the nearest whole number? So this one we would round to 5, because that 1 is just repeating. So it tells us that we're closer to 5 than we are to 6 or even 5.5. So we would use that same information if we were collecting our height of a fifth grader. Ignoring the fraction or rounding to the nearest whole number is reasonable in this situation, because the sum of all the students' heights is a large number of inches. It's not necessary to be exact, because we're just trying to find an average. If measuring something small like an insect, then we might need to round to the nearest fraction or decimal. And again, remember, you can use a calculator when you are collecting data. We're not trying to figure out, do we know how to add? We're figuring out, can we use this information to collect data and to analyze it? When we use a calculator, we can't type just in 1.5 or 1/2. We have to oftentimes type it in as a decimal. So you do want to remember those basic benchmarks for decimals, maybe half, 3/4, and so on, 1/4. So if we think about that before we move on, if we wanted to round to the fourth, we would remember that that is represented by a 0.25. 1/2 is represented, as we saw there, as a 0.5, and 3/4, you guessed it, it's going to be 0.75. You think about it as quarters, 25 cents. There's 4 quarters in a dollar, so one of them is 25, 2 would be 50, 3 of them would be 75, and if we get to 4/4, we're up to a whole. So in that orangutan math message, we would be able to collect that data and decide the answer, shorter or taller. So we're going to look at some other number lines, and you're going to look at page 208 and 209. There are going to be 3 different groups of information. We are going to focus on one today. So if you take a look at this, once it loads, and while that's doing that, I'm going to actually go to back to our journal, and I will find this to show you what you're working on. Okay, so you see on 206, that was to put some line plot of our class. We're not going to be using that. You can use that to help you through these problems on 207, but we won't be doing that class height data, but you can definitely use that number chart for your work here. So if we look at actually page, where's it gonna go? Let's pause this for a second. There we go, it was going slow for me. So you'll see on actually 208, 209, this is what we're gonna be looking at here. On 208, you see we've got emperor penguin heights, chimpanzee heights, red kangaroo heights. So we're going to use one as an example, and then I would like you to do a different one on your own. So for this purpose, I'm going to look at emperor penguins. says use the data in the line plot on journal page 208 to find the typical height of a, and so we're going to put that in here. So this is my example. I want you to do one on your own and look through it, okay, to work through this. So I'm just going to put or EP for emperor penguins. And then we're going to answer the questions to help us find the animal's typical height. Show your work in the space below. So they did give us space. So when you're looking at a line plot like this, we remember that the X's represent how many pieces of data fall on that benchmark. So it says, what is the combined total of all the measurements? This is where we can get kind of challenging. And because you see, we have lots of information here, lots of data. We can see we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 numbers that we're going to calculate together. So I like to organize it. And I'm going to look at my numbers here, and I see that we have whole numbers, and then there are some halves. So I'm going to put 41, and I know 41.5, because we're working with halves here, luckily. There's two 43s, so I'm going to figure out what's 43 times 2, and I know that that's 86. So I'm going to go ahead and write 86 here. So, and I'm just going to kind of mark these off as I go through them. I don't have to do any of these. I see 46.5 times 2. So I'm going to go over to my calculator. I'm going to clear it out. I'm going to do 46. All right. Too many tabs. 46.5 times 2. 46.5 times 2. 93. So then I'm going to go back to my journal. Let's move this over here. And I'm going to write 93. So I've got that one. Notice it's okay to use my calculator. And then I see 3 47.5. So I'm going to clear that. 47.5 times 3. 142.5. 142.5. Let's use this instead. So we can do 142.5. So we've got that. So I'm going to go through the rest of these, and I'm going to pause my video. When I come back, you'll see the rest of my thinking there. Okay, so I have added up each column. So you can see that I've narrowed it down. I don't have as many numbers. I'm going to do 41 plus 41.5 plus 86 plus 93, and so on. These are all of my pieces that I'm going to add together. I'm going to do these in the calculator, and then I will have a total of them combined. So what is the combined total? Because that's what I'm trying to figure out for this first one. Okay, so on my calculator, I've calculated them all together. I did several parts. I got 1,057. So I'm going to write 1,057 inches because that is the combined total. Now, you would like to check your work, check over it, because I could have easily made a mistake. Now we're going to look at number 2. It says, how many data points are there shown in the line plot? So that's where we're going to count all of our X's. So we see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. I know we counted that earlier, but we just want to double check. 21 data points. So we are going to have a number model here. If we think back to what we did when we were talking about these problems here, we took them all added and then we divided by the total we had. So looking back at this, I'm going to take 1,057, because that's my combined total, and we're going to divide that by 21 data points. That's what we have. So we're going to find out what the typical height of an emperor penguin, I keep wanting to put an M, emperor penguin, EP, and we're going to figure that out because we're going to take 1,057 divided by 21. So we're going to divide that by 21 data points, and I get 50.33333, so 3 repeating. I'm going to just round this to the nearest whole. I'm going to do 50 points. I can either do 50 or I could do 50 and a half. So I want you to think, what do you think that would be closer to? 50 or 50 and a half, which benchmark? Because it doesn't say to do whole inches. So I'm going to actually do 50.5 because I think that would be round closer. I know 3/10 is closer to 5/10 than it is to 0. So it says fill in the name of your animal and circle the word that completes the sentence based on. So we're not actually going to do this one for this lesson because we did not do the typical fifth grader for virtual learners. The main point I want you to get through this is to the collecting of the data, looking at it, and finding out the typical. And I want you to remember that the word typical means average. So we can go through all of this. So now I would like you to turn to page 210. And you've got some problems here that will be some good practice here, some good review. It says Hannah bought a package of 12 pens. She took 2/3 of the pens to school. How many pens did Hannah take to school? So you need to come up with your number model and how many. So this is a fraction of problem. Then we've got number 2, sorry. Craig is walking to a grocery store that is 3/4 mile away. When he is 1/2 of the way to the store, he ran into his friend Greg. How far had Greg walked when he saw Greg? So we've got another fraction of, but this one's a fraction of a fraction. And number 3, Lamar is researching postage stamps from different years. One stamp measured 7/8 inch by 2/3 inch. What is the area of the stamp? So we know by is telling us the area. So we know when we find area, we are multiplying. So these are all, practicing multiplying fractions. So you've got some things here I want you to do. I want you to go back to page 208 and 209, pick one of the other animals to complete these, to do some practice with that data, and then answer 210. So pause the video now and come back and check your work. For number 1, you should have found that we did 2/3 times 12 because it's 2/3 of 12 equals, we put P for pens, and we see that we get 8 pens. For number 2, we had 1/2 times 3/4 because it was 1/2 of 3/4, and we get 3/8 of a mile. Number 3, 7/8 times 2/3 because we were finding area, and we got 14/24. You could reduce this. You could put it in simplest form. It would go down. We could do 7/12 because we could take the top divided by 2 and the denominator divided by 2. I did not go over number 4, but you should have looked at Phoebe's class has filled 3/4 of a box with food donations. The class wants to collect 4 times as much. So we see 4 times, you get 4 times 3/4, and that's 3 boxes. And writing a number story that can be modeled using this would be good practice for you. 5/6 times 1/2. If we were to solve that, we could find that it's 5/12. And you should have a number story that's similar to this one here. Matt making a pizza with his family. They decided to cover 1/2 of the pizza with green peppers. Matt ate 5/6 of it. This is not required, but it would be good practice to connect with today's lesson. Once it loads. It is a home link 6.5. It is about data collection and putting it on a line plot and finding the typical or the average, and also some powers of 10 multiplying and dividing practice. The main point for today was working with that data in the line plots. So I really want you to go back, try one of those other animals if you did not, and work through the data that you saw there. So you could do chimpanzee heights or red kangaroo heights.